Hello there. So here is the second lesson for this week. We're going to be using Module 14, Lesson 1, decomposing fractions into sums. So we're continuing with fractions. I did skip a few modules. We're going to I just reorganized them, and they're going to be put at a later date. So I wanted to keep all the fraction information together, so that's why we went from 11 to 14. So you don't think that I made a mistake or anything. It definitely was done on purpose. So we are decomposing fractions into sums. So you're going to be decomposing visual fraction models into sums and model the decomposition with addition equations. So just when we're talking about sums, we're just talking about addition. So the sum is the answer when you add numbers together. Okay? So that's just to help you out with the vocabulary. So we have Megan, Zoe, Jack, and Gabriel, and they're sharing these pieces of watermelon. Some of the friends like watermelon more than others. Megan wants to eat the most pieces of watermelon. Jack wants to eat the same number of pieces as Gabriel. Zoe wants to eat more pieces than Gabriel. How could you represent the amount of watermelon each person will receive if they eat the rest of the watermelon? So this has a lot of moving pieces, right? This has a lot of parts to it. So let's just go back and let's just kind of check and see what is the information they're giving us. So we can see that they're going to share it, right? But Megan wants to eat the most pieces. So Megan wants the most. So she's going to be the greatest, right? She's going to be our greatest pieces. Jack wants to eat the same number of pieces as Gabriel. So we've got Jack and Gabriel want the same. And then Zoe wants to eat more than Gabriel. So Zoe wants to eat more than Gabriel. So Zoe's going to have to be in the middle, right? Because she wants to eat more than Jack. Jack and Gabriel want to eat the same, and Megan wants to eat the most. So that's kind of the transition, how that would go, right? So let's figure out how much watermelon each person will eat. So we could see how many pieces are left. 1, 2, 3, 4, 5, 6. There are 7 pieces left. So what I'm going to do is, I'm not a huge fan, and I know I've said this before, but I'm not a huge fan of using circles. I don't like drawing them and then trying to break them up because I never can do them with pieces that are the same size. So I'm more of a fan of rectangles. So I'm going to take my rectangle. Sorry, my camera's a little wonky today, or right now. I'm going to take my rectangle and I'm going to break it up into 7 pieces because I know there are 7 pieces left. I'm not going to worry about that 8th piece because it's just not there, right? We don't have the 8 pieces. We know that there are 7 pieces they're going to share. So I need to break this up into 7 pieces that are almost exactly the same. 1, 2, 3, 4, 5. Oop, that one's going to be a little bit smaller. 1, 2, 3, 4, 5, 6, 7. Okay, so we have our 7 pieces. So we know Megan's going to eat the most. We know Zoe's going to eat less than Megan, but more than Jack and Gabriel. So I'm thinking Jack and Gabriel. What if Jack and Gabriel each only ate 1 piece? They're eating the same amount. Then Zoe would have to eat 2 pieces because she wants to eat more than Gabriel. So then there would be 3 pieces left, which would give Megan 3 pieces. So did it solve all the requirements? Megan would eat 3 pieces. Zoe would eat 2 pieces. And then Jack and Gabriel would each eat 1 piece each. Would that work? Does that help make it so that everybody gets to eat the watermelon the amount that they wanted? Yeah, it sure does. So sometimes we need that picture, right, to help us solve our problem. Okay? So let's come to build for understanding. Tony and his family visit a state park. They grill 5 6-pound of hamburger for lunch. The hamburger is made into 1 6-pound patties. How many hamburger patties do Tony and his family have? So we're going to use a fraction model to represent the amount of hamburger Tony and his family have to grill as patties. The whole is going to represent 1 pound. So we know that they grill 5 6 for lunch, and the hamburger is in 1 6-pound patties. How many hamburger patties do they have? Well, first of all, we're going to use fraction models to represent the amount of hamburger Tony and his family have to grill as patties. The whole represents 1 pound. So if we have, here's our whole, it's 1 pound. They're broken up into 6, right? So we need our model to be broken up into 6ths. And then how much do they grill? They grill 1, 2, 3, 4, 5, right? 5, 1, 6. Because if it's 5 6 pounds of hamburger, and each is made into ones, and they're having 1 6-pound patties, they would have 5, right? 1 6. So what does each unit fraction represent in our whole? Each piece of this represents 1 6 pound of hamburger, or 1 patty, 1 hamburger patty, right? Because each hamburger patty is 1 6 pound. So how could we write an addition equation for this problem? Well, we know there are a total of 5 6 that they made for lunch, and each one was 1 6. So couldn't our equation look something like this? 1 6 plus 1 6 plus 1 6 plus 1 6 plus 1 6 equals 5 6. Right? So each one of those is 1 6. When you add them all together, 1 6 plus 1 6 plus 1 6 plus 1 6 plus 1 6, you get 5 6. So how many 1 6-pound hamburger patties do Tony and his family have? They have 5 1 6-pound patties. So because it was already in, right, 5 6 pounds of hamburger, they're 1 6-pound patties, so that's how you can tell there were 5 patties, because each one was 1 6 pound. Okay? So Tony and his family drove 7/12 of the distance across Michigan on Saturday. What are 3 ways they could break up the drive into 2 parts so they could stop and walk their dog? Shade the visual fraction models to show how they could break up the drive, then model each within equation. So, if they are driving 7/12 of a mile, or 7/12 of the distance across Michigan on Saturday, we need to break this apart into 2 parts. So, let's think about how we could break up our 7/12. So we know this part is our equals part, so we know this is going to be 7/12. So we're going to shade in 1, 2, 3, 4, 5, 6, 7 of them. So when I'm breaking my 7/12, sorry, I'm using my hands and you can't even see. When I take that 7/12 and I'm going to break it into 2 pieces, what could I do? Well, let's think about that. I know that 4/12 plus 3/12 equals 7/12, right? So 1, 2, 3, 4/12 plus 1, 2, 3/12 equals 7/12. That's one way they could break it up and have some time for their dog, right, to walk. So again, 7/12 is how much they're driving, or how much of the distance they're driving. 3, 4, 5, 6, 7. We're going to break it up. Let's try another one. How else could we break this up? Well, we could do 5/12, right? And 2/12. 5/12 plus 2/12 equals 7/12. So 1, 2, 3, 4, 5, 1, 2. Notice my twelfths is a label. When I'm adding, this denominator is a label. So when I'm adding fractions, if they have this, you need them to have the same denominator, and you're just going to add the numerators. And finally, 7/12. So again, we have 7. We've done 3 and 4, 2 and 5. We could do 6/12 and 1/12. So 1, 2, 3, 4, 5, 6, and 1. Right. Those are the combinations, right? Some different combinations that we could use to add those fractions together. Okay, so we're going to practice this a little bit. So we're going to first, I'm going to zoom us in a little bit more again, just because the print is too small when it's out that far. Okay, we're going to write 4, 6 as the sum of unit fractions. That means each piece, each unit. So if I have 4, 6, I have 4 1/6. So my 4, 6 equals 1/6 plus 1/6 plus 1/6 plus 1/6. Okay, the unit fractions are each piece. Now we're going to write the fraction as the sum of 2 fractions. Remember, sum is addition. So what could we add together to equal 4/10? Well, there are a couple ways we could do this, but one way is 2/10 plus 2/10 equals 4/10. What could we add together to equal 5 100ths? Well, we could do 3 100ths plus 2 100ths equals 5 100ths. There are other ways, right? We could do 1 100th plus 4 100th. Same thing over here. We could do 1/10 plus 3/10, right? There are other ways we could do it. That's just an example of what we could do. Okay? All right, and the independent part, the on your own, if you want to do this independently, you can do this, and then pause the video right now, do it independently, and come back and check your answers, or just stay right with me. Carlos buys this carton of eggs. He uses 5 eggs to make breakfast for himself and his sister. Draw a fraction model to show the fraction of the carton of eggs Carlo uses to make breakfast. So a carton of eggs is a dozen, right? So if we're going to draw our fraction model, we're going to draw like we did with like they drew for us right before. So this is going to be our 1 whole, and then we've got 12ths. So I'm going to go into half. Then I'm going to do thirds on each side. So that gives me 6ths. And then I can do each one of those in half, and that's going to give me 12ths. See how they're pretty close to being the same size, right? So each one of these is worth 1/12. Okay, I'm not going to use my blue because it's just going to cover up, so I'm just going to get a highlighter here. So, how many did he use to make breakfast? Carlos uses 5 eggs to make breakfast for himself and his sister. So we need to highlight or shade in 5 pieces, right, for the 5/12. Figure that's easier than me shading it in, then I'll just cover right up the blue. So what addition equations can you write to model the fractions of the carton of eggs Carlos eats and the fraction his sister eats? So there are a couple ways this could go, right? Carlos could eat 2/12. His sister could eat 3/12 of the eggs, and that would equal 5/12. Carlos could eat 4/12 of the eggs. His sister could eat 1/12 of the eggs, which would be 5/12. So you're just basically wanting to know what different addition problems could you come up with to add together to equal 5/12. Number 5, write the fraction as the sum of 2 unit fractions. Or write this, not 2, apologize, of unit fractions. So unit fractions is the individual fractions. So if we have 2/3, we know we're going to have a 1/3 plus a 1/3. This is the individual units. I apologize. I spoke too soon. We have fourths, and we've got 3 of them. So 1/4 plus 1/4 plus 1/4. 4/5, and we have 4 of the fifths. So 1/5 plus 1/5 plus 1/5 plus 1/5. Aaron and 3 friends equally share the pie shown, the rest of the pie shown. What fraction of the whole pie do Aaron and her friends eat? Write an equation to justify your answer. So we can see that they're going to eat what's left. This has already been eaten. Okay, so we're not counting what's missing. They're going to eat this. And there are 1, 2, 3, 4 pieces left out of a pie that was broken up into sixths. So if we have 4 sixths, they're going to eat 1/6 plus 1/6 plus 1/6 plus 1/6. Right? They eat 4/6 of the pie, and when you add up all those sixths, you get 4/6. Write the fraction 6/8 as a sum of 2 fractions in 3 different ways. So 3 different ways we could add 2 fractions together to equal 6/8. So if I have 6/8, I could add 3/8 plus 3/8. If I have 6/8, I could add 1/8 plus 5/8. And if I have 6/8, I could add, that needs to be an equals, 4/8 plus 2/8. Okay? So just make sure you're paying attention to whether they want the unit fractions or whether they want the sum of 2 fractions. Make sure you're noticing which is which. Unit fractions, you're going to need to do the single fractions added together. How many of them are there? Sum of 2 fractions is finding 2 fractions that can be added together to equal that fraction. Okay? So just make sure you're focusing on that and you're paying attention to that. Same thing with if you have to draw a fraction model. Make sure you have your whole, and then each piece is broken up into one individual, and then you just shade in what they've used or what they've done. Okay? So then go ahead and do the front and back of the independent worksheet for 14.1. When you're finished, return it to school, and I hope you have a great rest of your week, and I will see you soon. All right. Bye, guys.